Yo, what's up? It's your boy Mr. AC, and what I got for you guys today is going over primarily, and we are on year number, so let's go ahead and get started. All right, team, let us get rolling on the 2004 question, which was another great one, and I really like the fact that they're including absolute min or maximums, which is something I want us to make sure we get practice on. So let's go to part A. Before we get to part A, you can read the question, but you'll notice it's in the format. One of the two, either they're going to give you f prime, or if you look here, they're going to give you g of x equals, and we have the antiderivative of our integral from -3 to x f of t dt. So let us get rolling. So I went ahead and set up these for you because we've done a couple of videos now very similar to this. So g of 0, we plug in the 0 to the x value. Is it from most positive to most negative? It sure is. So from 0 to -3, 0 from -3, I need to find the area under the curve from 0 to -3. Well, if you look right here, this looks like a trapezoid, and even though it's on this negative side, it's above the x-axis, so I know that the area's got to be positive. So what do? Well, we take our widths, so it's going to be 1 plus 2 divided by 2. Let me make sure that I close this perfectly, right? This is one height, this is the other height, and then what's the width? The width is 3, so this is going to be 3 divided by 2 times 3, so 3 divided by 2 times 3. We're going to get 9 over 2, or this is going to be 4.5. You don't have to put the decimal approximation, but we know it's 9 over 2. All right, let's go to the second one. Well, it's asking for g prime of 0, so we need to show our work. So I'm going to write g prime of x equals, well, we do the derivative anti-cancel, we plug in the x, so this becomes f of x. Now I'm going to plug in my 0. Now to find what g prime of 0 is, I'm going to look at f of 0. Well, I'm given the graph of f, so I'm just going to look for the y value at 0. It's 1. There it is. So f of 0 is 1, and I'm done with these two subparts, and I would assume this would be a 2-point problem right here. Maybe even 1 point for this part right here. I'd have to double check it. So let's go on to part B. Part B, find all the values of x in the open interval at which g attains a relative maximum. So we need to find a relative maximum. Well, let me just draw a random graph for a moment. A relative maximum, we got to look for when the slope is 0. Right, 0, and then we take the derivative. This is going to be positive to negative. So we are looking for when our derivative changes from positive to negative. So if I go over here, I'm looking for when it's 0. Well, it's going to be 0 here, here, and here, right? Because if you look on what I wrote down below, g of x is f of x. So we're looking for, in this case, the y values of f to be 0. Now we need to look when it changes signs. Well, this goes from negative to positive. This goes from positive to positive, and this goes from positive to negative. So now, writing my little sign notation, I can see, we're going to have a relative maximum at x is equal to, is that 3? 1, 2, 3. So at x equals 3, don't get confused and think it's 4, right? This is 3. So how do I justify these again? Well, this is what I'm going to write. So how do I justify these perfectly? Well, I'm going to take this question and I'm going to frame it in the exact same way. G attains a relative maximum at, and then I'll go ahead and write at x equals 3, because g prime of x equals, real quick, not g prime of x equals f of x, sorry, I don't know why I put a prime on f. G prime of x equals f of x, changes sign from positive to negative, and that'll be my justification for B. So we got A down, we got B down. Let's go to part C, because part C is an absolute beauty. Let's go to it. Part C is asking, find the absolute minimum value of g on the closed interval. Now, absolute minimum value means the smallest y value, right? Remember, absolute is talking about the original. What is the smallest y value in your interval? Now, if I go to part B for a moment because it has space, just to remind you, look at the two graphs here. If I want to find my smallest y value, I need to check my endpoints of both graphs. I want you to see the difference between the two. And if you look on the graph number 1, you'll notice that the absolute minimum value is at the endpoint right here, right? You can see that it is the smallest y value. Well, if you look on our second graph, the absolute minimum value would be at our relative minimum. because the y values dip further down below than the endpoint. So when we find our absolute min or max, we need to check our endpoints. We need to find our relative mins and maxes. We need to find these values right here, and we need to test them and see which one has a smaller y value. Is it the endpoint or is it the relative minimum? So let's go ahead and go back to part C. Now, in this graph, it's asking for absolute minimum value. We already found that this point right here has a relative maximum because it changed from positive to negative. Well, if you look over here, this goes from negative to positive, right? So that means at -1, -2, -3, at -4, our graph has a relative minimum. I could care less about this relative maximum because it's asking only about absolute minimums. So this I can ignore. I can ignore this one because it's neither a relative min or max. So I'm going to put -4 in here. So I got my endpoints and I have the other values. So let's go ahead and begin to do them. Well, how do we figure these out? Well, it talked about G, right? This is technically G. So, well, what do? We plug it into the original. Well, what's the original? The original is just this function right here. This is our original. So let's plug these in. We're going to get G of -5. Let me go ahead and write it out. I went ahead and wrote all three out just because for the sake of time and you not hearing me have to click on my mouse every single moment. G of -5, we take it, we plug it into here. Remember, this needs to go from most positive to most negative, so we need to flip the signs. When we do, when you flip them, essentially you're flipping the sign of your area, so we put a negative in the front, or -1 times, and we get this right here. And so now I need to find the area under the curve from -5 to -3. So -5 right here, this right here, -5 to -3. Now here's the good news. Without calculating any area, I can immediately tell, hey, this goes to -2, this goes to +2. This is going to be negative area, this is going to be positive area, and they're the exact same. Because they're the exact same areas here, that's going to tell me that they're going to cancel each other out. So I don't actually need to find them. I'm going to get -1 times 0. And I'm going to get 0. So I can come up here and write 0. So this one was a very unique one. But the AP exam will sometimes do problems like this so that you don't have to spend forever finding the area. Some of these should cancel out. Now, if we go from -3 to -4, -3 to -4, now we're just talking about this area, which is the area of a triangle. So this is going to be 1 times 2 divided by 2, which is 1. So we're going to get -1 times 1 is equal to, and then we get -1 here. Now, just to briefly mention it, if I plug -4, it's going to be the same as up above. I'm going to have to flip the sign. So I did this all in one step. You don't have to go from here to here. You can immediately, if you notice, hey, I'm going to have to flip it, just go ahead, do it, put the -1, and you're golden. And you don't need to do any other work from that. Now let's go to -3 to 4. So -3 to 4. So if I want to find the area from -3 to 4, well, I want you to notice something, right? And this is where it's okay to do this. If you look right here, just for a moment, these two areas are going to cancel out, right? These areas cancel out. We don't need to get that area. I do need to get the area over here, but then I really can actually stop here. The reason why I can stop here is because just look at your graph. This area is going to be super positive. These little areas are positive. These areas are positive. There's going to be so much more positive area than negative area. And we're looking for the absolute minimum. So I can already conclude that this interval is going to be greater. This is going to be greater than 1, greater than 0. It's going to have area that is much more bigger than anything else. So this is going to be greater than 1 for a fact, right? We know it's going to be a lot. So we can conclude, hey, this is greater than 0, right? I'll put, you know what, we'll say greater than 0. Maybe not 1. I just chose 1 randomly, but we'll say, hey, this is greater than 0. This is greater than 0. So we can conclude that our absolute minimum value is -1. So I'll go ahead and write over here so you can see how it's going to look like. All you need to write down is the absolute minimum value of G on the closed interval -5, 4 is -1, and then this work right here is our justification. It's one of the only times on the AP exam when it says justify your answer that the work shown is basically your justification is -1. And there you go. That would kind of conclude our problem here. Now let's go ahead and finish up part D and we'll call it a day. Find all the values of x at which the graph of g has a point of inflection. That is our second derivative. That is when our second derivative should change signs. We're given the graph of f prime, so we need to take the derivative of this. Well, we're looking for when the slope is either 0 or undefined. Well, let's go ahead and think about it for a moment. Right here is undefined because it's a cusp. Right here it's undefined. Right here it's undefined, and then right here it has a slope of 0. So let's go ahead and think about this. If I take the derivative of this graph, I'm taking the derivative. This will be positive to negative, negative to negative, negative to positive, positive to negative. So how many points of inflection will this graph have? Well, it's going to have 1, 2, sorry, not this one, 1, 2, 3. These 3 are points of inflection. So I'm going to go ahead and write here. So the graph of, oops, I wrote UG. The graph of G, my apologies, the graph of G has a point of inflection, sorry, I wrote this so bad. My apologies, y'all, has points of inflections, right? Obviously, the AP exam would have marked you down for grammar mistakes. The graph of G has points of inflection at x equals -3, 1, and 2, because G double prime equals f prime of x changes signs at those values. And I spelled values wrong yet again. What is wrong with me? Values. Now I don't even know how to spell, but that would be my conclusion, right? Our second derivative changes signs, and there it is. We don't need to justify each one. We just need to state exactly how they change signs. So hopefully you guys enjoyed. That was 2004. Capiche?